8.3b, sine, cosine, tangent. So yesterday we learned about these new things, sine, cosine, and tangent. What are they? Yeah, they are fractions. Good. So they look complicated, sin, cos, tan, but all they are is fractions. So for number one, we've got a triangle, and it has a 90-degree angle, which is good because these fractions only apply to right triangles. And then it also has a 36-degree angle down here. And then this side is marked as 8. So what we need to keep in mind in the back of our head is there's a mini version of this triangle that has a 90 and a 36. And there's an enlarged version of this triangle that has a 90 and a 36. There's lots of triangles, lots of different size triangles that have a 90 and a 36-degree angle. But what do all these triangles have in common? Yeah. They have a 90-degree angle and a 36-degree angle. Good. What else do they have in common? Yes.
Oh, never mind.
Yes. They're similar triangles, meaning that this is just an enlarged version of this triangle. Okay, so if they're similar, what's true about their sides, Jennifer? The fractions are equal. So the sine and the cosine and the tangent is going to be equal for all of these triangles, because sine, cosine, and tangent are fractions. So on this triangle, this fraction is going to equal this fraction is going to equal this fraction. And this fraction is going to equal this fraction is going to equal that fraction, because all these triangles are similar. But they want us to look at this particular triangle that has an 8 on the hypotenuse. And they want us to find the missing sides. Okay, so in order to do that, we need to know what the fraction is for 36. Because apparently this fraction equals this fraction equals this fraction, because they're all similar. So we need to know what that fraction is. So I'm going to pass out a table that tells you what that fraction is. Okay, before we get there though, let's go for this side first. I'm going to call it y. So y, is that hypotenuse or adjacent or opposite? Yeah. Good, it's adjacent. The reason it's adjacent is because it's next to the 36. So y is adjacent. What about the 8? Yeah, hypotenuse, right? Is everybody with him? That 8 is hypotenuse and y is adjacent? Okay, so we're going to make the fraction adjacent over hypotenuse. So that's y over 8. And then, so this is going back to yesterday. Which of these is adjacent on top and hypotenuse on the bottom? Yeah, Emma? Cosine, good. So we put the adjacent on top and we put the hypotenuse on the bottom and we made a fraction. But yesterday we learned that the name for that fraction is cosine. So this fraction, the name of it is cosine of the 36. All right, so like I said, this cosine 36 apparently is a certain number. Because on all these triangles, this fraction equals this fraction equals this fraction. So we're going to look at this piece of paper that I'm going to give you and look up the cosine of 36. And then that'll help us solve this problem. So this is yours to keep. I don't give you many sheets of paper, but you get to keep this one. And you'll use it as reference for the next, well, for the rest of the class. All right, so there's a lot of numbers on this chart. Lots and lots of numbers on this chart. But we're trying to find 36. So, do you find 36 on there? It's like 2/3 of the way down, or even more than that. Are you seeing 36? Okay, and then you want the cosine of 36? So it's the cosine column is 2 over. You see the cosine column? All right, so cosine 36 is 0.8090. Everybody finding that? It's totally fine if you're not finding it. There's tons of numbers on here. Does everybody see the 0.8090? Are you sure? Okay, so I just looked that number up on the table. So this table knows what the cosine of 36 is. And the reason it knows what it is because this fraction is the same as that fraction is the same as that fraction on all these 36 triangles that have a 90. All right, so now I'm just going to recopy this equal sign and recopy the y over 8. Now I need to write this as a fraction because it'll be easier to solve if I put it in fraction form. So this is going way back to like 5th grade. No offense to you, I just know it's been a long time. That's the tenths place. This is the hundredths place. That's the thousandths place. So that's the 10,000ths place. So that means that this is a fraction out of 10,000. And it's 8,090 out of 10,000. So again, it's been a long time since you talked about this, but decimals are just the shorthand for fractions. Like 0.2 is 2 out of 10. So this is 8,090 out of 10,000. So I just decided it would be easier to see this as a fraction. So that means somewhere there's a huge triangle, even bigger than this, that has a 36, where this is 8,090 and the hypotenuse is 10,000. But we have a scaled down version of that triangle, where it's 8 on the hypotenuse. So we're going to still equal this to y over 8. So we got to take the 10,000 hypotenuse on the huge triangle and scale it down to only 8. And then we're going to take the 8,090 and scale it down to whatever it is. So how do you solve this? Yeah. Cross products, right? When you have two equal fractions, you do the cross product. So we're going to do y times 10,000. So that's 10,000y. And then 8,090 times 8. So that's 64,720. So I just did that times that, and that times that. That's how you deal with any, when you have two equal fractions, that's how you deal with it. And then you divide the 10,000 to the other side. And it comes out to 6.472. So there's a very large triangle where this is 8,090 and this is 10,000. But we have the scaled down version of it where this is 6.472 and that's 8. But 6.472 over 8 is the same fraction as 8,090 over 10,000 because the triangles are similar. All right, now we're going to go for this side. So I'll call that x. So 8 is the hypotenuse. What's the x? Compared to 36, yeah. It's the opposite, right? Because it's across from the 36. So now we've got opposite and hypotenuse. So that's x over 8. So I just made a fraction, opposite over hypotenuse. All right, so from the ones we learned yesterday, remember we learned 3 fractions yesterday. Which one is opposite and hypotenuse? It's the sine. So we made the fraction opposite on top, hypotenuse on the bottom. So that means we made the sine fraction. So this fraction is the sine of 28. Sorry, not 28, 36. Everybody doing okay? Okay, so now I need to know what the sine of 36 is. So where do I find that answer? On the table. So sine 36, 0.5878. And then that's 5,878 out of 10,000. Then you do the cross products, 5878 times 8. And then finally divide by 10,000. So that means this side over here is 4.7 inches or so. Okay, I want to temporarily skip to 4a and 5a. And those are both the same question. They both say the sine of 50. So if they're asking for the sine of 50, what is your answer going to look like? If they're asking for the sine of 50, what is your answer going to look like? What are sine and cosine or tangent? Yes, they're fractions. So if it's asking for the sine of 50, your answer is going to be a fraction. How do you find the sine of 50 fraction? Look it up here. So find 50. Find the sine, 0.7660. Okay, but that doesn't really look like a fraction, so I like to convert it to a fraction form. It's 7,660 over 10,000. So they asked for the sine of 50. That means I'm looking for a fraction. So there's the answer. Okay, but this problem here, I want to point out that your calculator also knows the sine of 50. So you don't have to use this table to look up sine 50. You can type sine 50. Okay, so if you have your calculator with you, please, some people's are messing up a little bit, so I need to know whose are messing up. So type sine and 50. Are you getting this number? Okay, you're not? That's good. That's okay. So press mode. It's right next to the blue button. And then about 4 down, it says radians and degrees. So tab down to there and light up degree. And press enter when you're on top of degree. Good? Okay, now go back and redo sine 50, and you should get this. Okay, good. Anybody else getting the wrong answer for sine of 50? Because if you are, I need to fix your calculator just like I fixed Jennifer. All right. So what do you notice about this number compared to that number? This has got more decimal places, right? So this is a rounded answer that the table has. This is closer to the right answer. Crazy thing is, this still isn't the right answer. The right answer goes on forever. You know how we've been dealing with square root of 2? And we don't want to bother with that decimal? Same thing's happening here. That's why we call it sine 50, because we don't want to bother with this decimal. But for today, it's okay to round, so that's why we're going to get this answer from the table, and this answer, which is a little bit better from the calculator, but neither are correct. Yeah, neither are exactly correct. All right, now let's go back to 2. So there's a triangle on number 2. Not surprising. It has a right angle, which is not surprising because I should keep mentioning this. The sine and the cosine and the tangent, they only work on right triangles. What else works on right triangles? There's a formula we've known for a while, yeah. Pythagorean Theorem works on right triangles. So this is adding to the Pythagorean Theorem. All right, so this one has a 28-degree angle up here. And it's 4 on this side. And x is here, and y is here. Okay, so we have to find the missing sides. So what do you want to go for first? Do you want to go for x or do you want to go for y? It doesn't matter. All right, y. Oh, that's y? Okay, so he's going for y. He's not really giving us a reason. He just keeps repeating the question. But we're going to go for y just because. Doesn't matter. We could go for x first. All right, so 4. Is that opposite or adjacent or hypotenuse? Yeah.
It's opposite.
So you have the 28 and the 4 is across from it. So 4 is opposite. Okay, and then the y. Is that hypotenuse or adjacent? Yeah.
Adjacent.
It's adjacent because x is hypotenuse. So we are going for the adjacent, and we have the opposite. So we're dealing with opposite and adjacent. So which one of these, sine, cosine, or tangent, which one of those is opposite and adjacent? Probably don't remember. It's okay. You can look on your note card. Yeah, Alex? It's the tangent that's opposite and adjacent. Okay, so we're going to make the fraction opposite over adjacent. So opposite's on top, adjacent's on the bottom. And yesterday we learned that the name for that, the fancy name for that fraction, is tangent. So that's the setup. And we're going to do some math to figure out why, but this is the setup. Is everybody okay with the setup? All right, so now we can look this number up. We can either look it up on the calculator or we can look it up on the table. Doesn't matter, whichever you have handy. So tangent of 28. .5317. Everybody seeing that? So I just wrote down .5317. That's what the tangent of 28 is. And I just recopied 4 over y. Then it's easier to deal with if it's a fraction. So I'm going to put 5317 over 10,000. So 4 over y equals 5317 over 10,000. Everybody still okay? Then you do the cross products. So 4 times 10,000 is 40,000. 5317 times y is 5317y. And then you divide by 5317 to get the final answer. So I'm getting 7.523. All right, so that gives me y. Now I've got to go for x. X is hypotenuse. 4 is opposite. So now I'm dealing with opposite and hypotenuse. Which one of those is opposite and hypotenuse? We learned them yesterday. It's the sine that's opposite and hypotenuse. So I'll put opposite on top, hypotenuse on the bottom. And that equals the sine fraction. So then I look up sine of 28, either on the table over there or on the calculator here, is 0.4695. So then 4 over x equals 4695 over 10,000. Then do cross products. 40,000 equals 4695x. That comes out to 8.52. All right, last one, number 3. Here's what the triangle looks like. Do you recognize this triangle? Yes. It's a 45, 45, 90 triangle. So that means we don't have to use what we learned today. We can use what we learned last week. So on a 45, 45, 90, we learned that the leg times the square root of 2 was always the hypotenuse. Here's the formula. Hypotenuse equals leg times square root of 2. So they gave us the hypotenuse. So that means that the leg is 10. So this one is easier because it's one of the special ones we learned last week. 45, 45, 90. This is 10, and then this is 10 root 2. What's this? 10 also. Remember the 45, 45, 90 is isosceles? So that means both of these are 10. So y is 10 also. Okay, so sine, cosine, tangent, they're new, but they're just fraction.